Hi everyone, my name is Julia and I was the one that was shipped from Canada. So I'm very happy to be here today to tell you a little bit about how the brain allows us to mentally wander away from the here and now. So there are many ways to define mind wandering, and one way is very nicely captured by this image here. These are students in a science class learning about the brain. So as you can see here, some of them are fully paying attention to the lesson and thinking about the brain, while others may be thinking about the basketball game after school or that mint chocolate chip ice cream that you had last night. And this is precisely what we refer to as mind wandering. These are periods of time when you're thinking about something that's unrelated to the ongoing task, whether it be attending a class or reading a novel. So you might ask, how do we study something that is so subjectively experienced that it only exists in our own minds? Well, scientists have come up with several ways, one of which is called experience sampling. This is where an experimenter occasionally and at random intervals asks the participant about their inner experience. So imagine you come into a lab and you do this boring computer task where you have to detect a soccer ball while you're being presented with all kinds of other balls. And then occasionally you see this blue screen that pops up that asks you, just moments before you saw that blue screen, were you fully attending to detecting that soccer ball, or were you thinking about something else? So this is a more subjective but very direct way of asking somebody about their experience. A more objective but less direct way of understanding mind wandering is through electroencephalogram, or EEG. This is where we put electrodes on participants' head and then measure their brain activity over time. One way to look at EEG data is to average our response to the same occurring event, here a basketball, over many occurrences, and then time locking it to that event, where we then end up with a waveform. Let me grab a laser. Or not, where we see a waveform that unfolds over time. So here we see that time is plotted on the x-axis, and then the peaks and troughs in the waveforms indicate specific processes that our brain engages in response to that event. So the size of the peak and trough, which is plotted on the y-axis in voltage, is indicative of the magnitude of the response. Okay, so if listening to my talk is your task right now and you're my participants, I would ask you whether, just moments before this blue screen popped up, whether you were on task or mind wandering. You don't have to answer that question. Not out loud anyway. So this is actually an example of experience sampling in the real life. So using a combination of experience sampling and EEG, some scientists have found that mind wandering disrupts our interaction with the environment. Here we see an example where the green line indicates our brain's response during mind wandering, and the gray line indicates our brain's response during on task. In that highlighted time window there, we see that the peak shown on the green lines during mind wandering is smaller than the peak in the online periods. And what that tells us is that we process information to a lesser extent when we're mind wandering. And here in this example, the peak reflects this sort of cognitive level processing, but we also see the same pattern holds for all kinds of other processing at the sensory level, error processing, and so on. So what this really tells us is that there's this widespread attenuation or disruption of our response to the environment. But now you might ask, if we spend so much of our time mind wandering, and if mind wandering disrupts our response, then why is it that we don't bump into people more often than we would, or make more mistakes than we would normally? And that's because our ability to detect unexpected events is actually preserved during mind wandering. So imagine you're just walking to school one day, and you're just kind of taking the same route that you take every day. And you're becoming deeply engaged about what you want to do this weekend. Everything that sounded really clear to you becomes background noise. And then all of a sudden, you hear this loud, constant honking that snaps you out of your mind wandering. Your attention becomes re-engaged with the environment, and then you know to stop right away before this car approaches you. And that altogether, what this really tells us is that, when we're in our safe and typical environment and we're mind wandering, our brain is pretty good about shutting down everything that happens in our environment. That is until something that is unexpected, unusual, and potentially dangerous occurs. Thank you.
So, Wyatt, I think you get the mic.
Yeah.
So, on the article, you said that most people only mind wander for a certain amount of time. Is that set in stone, or can that vary for the person?
Yeah, you're right. I mean, I think there are huge individual differences. So there are some people who may mind wander for long chunks of time and all the time, and then there are people who may mind wander at a little bit at a time. And so there are definitely differences between individuals.
Do you have a follow-up for her? Is that-
If you're mind wandering about the task at hand, but not exactly, like you're thinking about the task at hand, but like you're thinking about, oh, when this is finished, I'll be able to use it in so-and-so or something. Is that considered mind wandering full on, or just thinking about the task?
That's a really, really good question. Let me think about this. So, if you're mind wandering about the task, so for example, you might think, oh no, I just made that mistake. You're still thinking about the task, yeah? But then you're no longer fully paying attention to what you're currently doing. So in that case, at least in some of the experiments that we talked about in the paper, that would still be considered as mind wandering. But there are a lot of different ways that scientists define this experience, and I think you're getting at a really important difference there.
Krishna.
Sorry. You say people are reporting if they're mind wandering or not, and it might not be 100% accurate because personally I don't want to say I'm mind wandering all the time, but isn't there, like, couldn't you do another way, such as like having a button and like where you're looking at the pictures, like a bell rings in the background, and if you click the button that means you heard the bell, and if you no, that means you're mind wandering?
I think that's a really great idea for my next experiment, thank you. Yes, no, you're absolutely right. I think there are definitely a lot of criticisms about the experience sampling method, and you pointed the main one, which is how do we know that the participants are being truthful and honest? And just like you said, there are other ways that are actually used to help us confirm that what the participants are reporting are accurate. So for example, EEG is something that they're less able to control, yeah? Or maybe the pupil diameter, it's also something that we cannot control very consciously most of the times. And so if we have different measures that we take that seems to all confirm what the participants are reporting, then we're more sure that what they're reporting is reflective of what they reported.
What part of the brain allows you to snap out of mind wandering?
That's a really good question. So you're talking about the part that actually catches our attention right away and then brings us back to the environment. There is this part called the anterior cingulate cortex that's sort of it's really right inside our brain, and the insula, and both of them have actually been shown to help facilitate that process that grabs our attention and then brings it back to the environment. Yeah.
Any other questions? Yeah, there is.
Which parts of the brain are specifically the most active while mind wandering versus ordinary tasks, and how do those correspond to the parts active when performing other tasks, such as dreaming, for example?
That's a really good question. So there's these network of regions called the default mode network that has been shown to be more active when we're engaging in our own thoughts than compared to when we're actually doing something that's related to the external world. With dreaming, however, it's actually been shown that it also activates a very similar area that's overlapping with the default mode network. So what's been found actually is that daydreaming or mind wandering actually is very similar in terms of the areas that they activate compared to dreaming, which happens at night.
So is it more likely to catch your attention if you're walking and you see a car, would you snap out of mind wandering, or is it more likely for like a sound to interrupt your mind wandering?
Yeah, so I don't think that it's specific to a particular sensory modality, like either something that we see or hear. I think it's more about something that's unexpected. So it could be a sound or it could be something visual. So if you see someone walking while you're driving, then that could also snap you out of your mind wandering as well, even though that person may not have made a sound.
So Payson, you have the last word.
Can people act normally when they mind wander? Like, for example, can they have a conversation, or can they just like mind wander and not like act normal?
Yeah, so I think we can do a lot of things and mind wander at the same time. And these things are typically tasks that we're very, very familiar with. So for example, do you think you can walk and mind wander at the same time? Yeah. What if you're learning a new task, like you're playing the piano and you're learning it for the first time? Do you think you can mind wander and then maybe play the piano at the same time if you don't really know how to play the piano yet? Yeah, so I think there are times when if you're really familiar with the task, then you can maybe mind wander and do the task at the same time, but it will be really challenging if it was a task that you've learned to do for the first time.
So I'll ask Randolph to start setting up the next presentation as we decide, well, is this a outright accept? Is this a revise and resubmit? Or are we rejecting? Well, I'm going to let Sabine speak first, Wyatt, and then Zaid.
Accept.
Sabine accepts.
you.
All right.
I think that you should revise it a bit and then submit, because there were a lot of abbreviations in the article, and it would be a bit easier to like just read the article if the abbreviations were like the actual thing written out, or like you could refer to them using pronouns instead.
Thank you for the suggestion.
Great. So in journal speak, we can do a minor revision where you don't have to do any data analysis or additional data collection, or we could do a major revision. So we're thinking this is probably minor. Is that good? All right, great. Minor revision. Thank you, Julia.